Hi guys, in this video we are going to start the second half of chapter 7, and I teach the sections in a slightly different order than the book does, so that's why I'm just going to call this 7.4 and 7.7 combined. We're going to start factoring. Some of you may remember factoring from last year. And so what we're going to start with is the greatest common factor, and I have the definition here. So first the definition of factoring. So when we rewrite a polynomial as a product of its factors, it's called factoring. And the first thing that we need to check for when we factor is something called the greatest common factor. And the greatest common factor is the largest factor that two or more values share. So if you need a reminder about what a factor is, two examples is that 2 and 3 are both factors of 6 because you can take 2 and multiply it by a number, 3, to get 6. So that's the definition of a factor. And the thing that I'm going to be saying over and over and over again that you'll hear in the coming days and weeks is that we always need to check for a greatest common factor first. When we start this whole factoring process, we're going to start with just the greatest common factor, but when we get to more complex problems, that will be the first thing that we want to check is the greatest common factor. So we need to be able to determine what the greatest common factor is given a set of values. So between 6 and 8, it's not one thing that you have to remember before we do the example is that it's not the least common multiple. They are very easily confused. So what you can do is you can always list out factors of your values and see which one is the largest that they share. So if I were to make a list of all the factors of 6, it would be 1, 2, 3, and 6. That's it. And then of 18, it would be 1, 2, 3, 6, 9, and 18. And I believe that's it. So we're looking for the list that I've created, the two lists that I've created. I'm looking for the largest factor that they share, and the largest factor that they share is 6. So 6 is my greatest common factor of both 6 and 18. So for 4 and 17, my factors of 4 are 1 and 4, and my factors of 17 my factors of 4 are 1, 2, and 17, or 1, 2, and 4. Confusing myself. And then of 17, it's 1 and 17. So the largest factor that they both share is 1. So 8x and negative 28. So what we can do is we can look at our numeric values first. So I see that there's a variable in there, so that's let's just deal with the numbers first. So between 8 and 28, the greatest common factor is going to be 4. Okay. So then I have x, and I don't have a variable here. So they need to share the value. So since I don't have an x attached to 28 or an x squared or anything like that, then the greatest common factor is going to be 4. Okay. So when you're factoring out a variable, so for the fourth one, 2x to the third, or when you're checking for a greatest common factor, 2x to the third minus 8x squared plus 6x. So all of the terms need to have a variable. So that's why I couldn't factor, or my greatest common factor for number 3 didn't include a variable. But for number 4, all of my terms contain a variable. Okay, so with variables, the greatest common factor is always going to be the variable. So it's going to be the variable with the lowest exponent. Okay. So between 2, 8, and 6, just looking at the numbers, 2, 8, and 6, greatest common factor is 2. Between x cubed, x squared, and x, the GCF is x. So my greatest common factor is 2x. Okay. So factor out a greatest common factor. So we're going to take that greatest common factor and actually start factoring. So first we need to identify what the greatest common factor is. So I look at it in two pieces like I did for the previous two examples. I look at the numbers first, then I look at the variables, and the number and the variable is going to make up my greatest common factor as long as I have a variable to factor out. So between 4 and 24, my greatest common factor is 4. And between x to the 4th, and I'm actually going to give myself a little bit more room, so I'm going to write this a little lower. So between 4 and 24, my greatest common factor is 4. And between x to the 4th and x squared, I take out the smallest exponent, as long as all of my terms have variables. So my greatest common factor is 4x squared. Some of you might be wondering why it's not x to the 4th, since it's not the largest. Well, think about what you can multiply. If I took x, let's say my greatest common factor was x to the 4th. What can you multiply that to get to x squared? And if you're having a hard time coming up with it, that's because it would have to be a fraction value. So we don't, or a negative value actually. And we don't want to deal with negative exponents. But on the flip side of that is what can you take out of x to the 4th? So you can multiply x squared times x squared to get to x to the 4th. And remember that the definition of a factor is something that multiplies to another value to get your desired result. So x squared is a factor of x to the 4th, but not the other way around. X to the 4th is not a factor of x squared. Okay, so that's why we take out the smallest exponent. So then when we're actually factoring it out, so we have our greatest common factor listed below. So if we want to bring that out, then what we're doing is we're multiplying in reverse. So that means that we're dividing. So we're going to divide our greatest common factor that we just found by both of our terms. Okay. And this is the process of factoring it out. So when we divide 4x to the 4th by 4x squared, then the 4's cancel out, and if you remember, we subtract the exponents. So that just equals 1, and x to the 4th over x to the 2nd is x to the 2nd. And 24x squared over 4x squared is positive 6. The x squareds are going to cancel out. Okay. So I have 4x squared times x squared plus 6. Now I could always check my work and make sure that if I multiply this out, which is what we've been doing for the past couple of class periods, if I distribute 4x squared to both these terms, I actually end up with my original problem. So that's how I know that I factored it correctly. But we leave our answer in factored form. Okay, so the greatest common factor between 8y squared and negative 24y is 8y. Now, if you're having trouble identifying the greatest common factor, just come and see me and I can give you some more example problems. So 8y is my greatest common factor, and the process to factoring out a greatest common factor is we divide that greatest common factor by our terms. So 8y squared over 8y is just y. Negative 24y squared over, I keep saying the wrong thing, negative 24y over 8y is negative 3. Okay. And that's our answer. Again, if you wanted to check it, multiply it back through, you get to your original problem. So try this one on your own. You can pause the video, and when you are finished or you think you have an answer, then unpause it and check. And that should be your answer.